Okay, so you might have drawn hydronium as something like this, and you're not too far off. But let's go through our three rules to see where we're going wrong ever so slightly. Okay, so if we wanted to think about our three rules again, so this would be our checklist. The first thing we said we were always going to really worry about is the octet rule. So let's think about the octet rule for the oxygen. Right now, this oxygen has 2, 4, 6 electrons that are surrounding it. So although we are not breaking the octet rule, we're not really fulfilling it either. So there's something a little bit wonky going on. So the octet rule, again, a very important point to make is that the octet rule just says that we can't go above 8 for this particular atom. Okay, so oxygen cannot sustain any more than 8 electrons that are surrounding it at the moment. So thinking about how many we do have, we only have 6. And so we're not really breaking the rule, but at the same time, we're not really fulfilling the octet rule. Okay, so there's something weird going on here. So the next thing is the duet rule. Let's think about the duet for each one of these hydrogens. So each one of these hydrogens shouldn't have more than 2, and right now we have 2 for this one, 2 for this one, and 2 for this one. So it seems like we're doing okay with the duet rule. Okay, so now let's just put that aside for a second and think about the valence. So if we were dealing with just a neutral molecule, we would have, if we added up all of the electrons, we would have 6 electrons for this one oxygen, and then for each one of the hydrogens, we would then add another. So 1, 2, 3. So we would have 6 plus 3 is going to equal 9. Okay, so if we had a neutral molecule, we would be assuming that we would assume that we would have 9 electrons to deal with. But you have to remember that this hydronium is positively charged, so we're going to subtract 1 from that. Okay, so we really only have to deal with 8. So now let's go back to the molecule and count how many total electrons we really have. So right now we have 2, 4, 6. So 8 versus 6, there's something going on here. One is a little bit higher than the other. So what this should tell you is that we've neglected to put in 2 electrons. So this 6 count is wrong, and we should have a total of 8. So the easiest way to figure this out, or to fulfill this deficiency of 2, is just to go ahead and add 2 more electrons to the oxygen, so right here. So right now if we go back to the octet rule, we can say, okay, how many electrons are surrounding oxygen? 2, 4, 6, 8, and now we've fulfilled the octet rule. So that seems pretty good. Okay, so now we've fulfilled the octet rule, and we've fulfilled this 8 electrons that we needed to fill in somewhere along the way. Okay, so there's still something wrong with the way that we've drawn this hydronium. And if you can take a second, pause the video, see if you can figure out what that is. More than likely, you've noticed that the charge calculation is not going to work out right. So this guy right here is neutrally charged, and this hydronium right here is positively charged. So if we were going to go through this charge calculation, it would look a little bit different than before. So go ahead and, again, try to pause the video, go through this on your own, and see if you can do the formal charge calculation for the oxygen as well as the hydrogen. Okay, so hopefully you would have gone through the formal charge calculation for the oxygen like this. So you always start off with the formal charge, or the valence for the oxygen, and the valence for the oxygen is 6. Always, always, always. Then what we're going to do is subtract the total number of covalent bonds. So for the oxygen we have 1, 2, 3. So there's your 3. And then we subtract the total number of electrons that exist as lone pairs. So in that case we have 2 total electrons that exist as a lone pair. Okay, so now it's going to be 6 minus 3, which is 3 minus 2 is going to be plus 1. So we should see that this oxygen should have a plus 1 formal charge.